When dealing with an oddball range such as minus 10 volt DC to 10 volt DC, it's very simple to get the equivalent values. All that you do is you get the percentage of that full range from the minus 10 to the plus 10, and you add that to the lowest value, which in our case is going to be the minus 10. Let's go and say that we want to measure a maximum flow of 2,500 cubic meters, and the minimum flow is going to be 0 cubic meters, and we go and get a value of 980 cubic meters, and we want to know what the equivalent signal of that is going to be. Well, the first part is nice and easy. We're just going to go and work out what percentage we are looking at, and that's going to be very simple. In our case, the percentage is going to be 980 divided by 2,500, and we'll go multiply that by 100 to get it into a percentage, and that should give me a value of 39.2%. So we start off knowing that we're going to have to work with 39.2% of the total value of minus 10 to plus 10. And now it becomes very, very easy. All that we're going to do is we're going to take the lowest value, which is the minus 10 volts, and we're going to add that to 39.2% of that full range of ours, which is going to be from, if you take the upper range value, 10 volts minus, and remember that's minus 10, that should give us a value. So we're going to look at minus 10, which is going to be added to 0.392, and from minus 10 to plus 10, or 10 minus minus 10 is the same as plus 20. That's going to be multiplied by a value of 20. And if you do go and do that sum, you're going to end up with a value of minus 10, which must be added to 7.84 volts, and if you put those together, your final reading is going to be minus 2.16 volts DC. And that is it. That is how we can go and do such a conversion.